This homework assignment is going to go over problems 1, 3, and 5 so that you have this as a reference to help you with the other problems. So in problem 1, we have the equation y equals 2x squared minus 12x plus 16 in standard form. So we're going to take this equation, put it into its vertex form, find its factors, its roots, its vertex, domain, range, increasing and decreasing interval. So I can find its vertex straight from here by doing negative b over 2a to find the x value and then plugging it back in. Okay, if I did that, that would be no problem, but it would be doing some extra work if I already have to find the vertex form. So I'm going to go ahead and just start by finding the vertex form. So I've got 2x squared minus 12x plus 16. So I know my a is 2, so I have to go ahead and divide by that first. So I divide by everything by 2. Once I do that, then I have to subtract my 8 to move it to the other side. Okay, remember this is the process called completing the square. So my b term is negative 6. Half of negative 6 is negative 3. Negative 3 squared is 9. So I'm going to be adding 9 to both sides. So I combine my like terms over here. Negative 8 plus 9 gives me 1. And then I'm factoring x squared minus 6x plus 9. So this factors to be x minus 3 squared. Now I want to move my constant term back over, so it's plus 1, so I'm subtracting 1 from both sides. And then lastly, I want to get rid of this 2, so I have to multiply both sides by 2. So I get y equals 2 times x minus 3 squared minus 2. So this tells me that, first of all, my vertex form, y equals 2 times x minus 3 squared minus 2. It also tells me that the vertex is a positive 3 and a negative 2. Okay, now that is going to help us be able to tell us our increasing interval and our decreasing interval. Because in general, we know that this parabola opens up. So if I think about it, I'm just going to draw a rough sketch without even an xy axis, just knowing the vertex here is at positive 3, negative 2. Okay, it is increasing on this side of my graph. And I'm always looking at the x value. So it starts increasing at 3 and it stops increasing at infinity. Okay, it starts decreasing at negative infinity and it stops decreasing at 3. Domain is always all real numbers, and the range is always dependent on the y value. Okay, it points up, so range is everything greater than or equal to the y value of my vertex, which in this case is negative 2. Alright, so all we have left here are to figure out the factors and the roots. So we go back to our original equation. We set it equal to 0. 2x squared minus 12x plus 16. We factor out our greatest common factor. Whoops. So that's a 6x plus 8. Okay, so we're looking for numbers that multiply to give us a positive 8 and add to give us a negative 6. So that's negative 4 and negative 2. So x squared minus 4x minus 2x plus 8. So we can take out an x here, and that leaves us with x minus 4. And we take out a negative 2, and that leaves us with x minus 4. So when this is completely factored, it's 2 times x minus 2, x minus 4. Now be careful, do not leave out this 2. So our factors are 2, x minus 2, x minus 4. Okay, so that tells us our roots, because the 2 doesn't give us one of our roots, but the x minus 2 equal to 0 will give us our root, and the x minus 4 equal to 0 will give us a root. Gives us a root at x equals 2 and at x equals 4. So 2 and 4 are both roots. Alright, so we'll take a look at problem number 3, where it's given to us in vertex form. And I know it's a little fuzzy to read here, but you do have it on your worksheet in front of you. So it's given to you as y equals negative x minus 5 over 2 squared plus 9 over 4. So we know right away the vertex is a positive 5 halves and a positive 9 fourths, because it's the opposite of the number inside the parentheses and it's the same as the number outside of the parentheses. So we can't go straight from the vertex form to the factors. We have to go from the vertex form to the standard form first. So keep this negative sign, and I'm actually going to write it as a negative 1. X minus 5 halves, x minus 5 halves, plus 9 over 4. Okay, it's easiest to FOIL these two things together first and then distribute the negative 1. So x squared minus 5 halves x minus 5 halves x plus 5 halves times 5 halves is 25 over 4. And then plus 9 over 4. So now we're distributing the negative 1 through, so it's negative x squared plus 5 halves x plus 5 halves x minus 25 fourths plus 9 fourths. Now we can combine everything together. And it looks like I dropped my y equals here at the beginning. I really didn't want to do that, so I'll put it back in. Negative x squared, 5 halves x plus 5 halves x is 10 over 2x, which is really 5x. And a negative 24ths x plus 9 fourths x is a negative 16 fourths x, which is really just negative 4. So this is our standard form. Y equals negative x squared plus 5x minus 4. So we want to see, is this thing factorable? In order to factor, I never am able to tell if it's factorable or not with a negative sign out front. So I always just take out a negative 1 and make it be x squared minus 5x plus 4. So it's easier for me to tell if I'm looking for numbers that multiply to give a positive 4 and add to give a negative 5. And I can tell by looking at that that that's not factorable. So right here, I'm writing not factorable. But that does not mean that I can't get the roots. Okay, so to get the roots, I'm using the quadratic formula. Okay, so you're using this equation right here. So the opposite of b plus or minus the square root of b squared minus 4 times a times c . all over 2a. So that's going to be negative 2. So this is going to be negative 4 times a negative 1 is a positive 4. Positive 4 times a negative 4 is going to be a negative 16. So it's 25 minus 16, which is going to be a positive 9. So we have negative 5 plus or minus the square root of 9 all over negative 2. Negative 5 plus or minus 3 all over negative 2. So negative 5 plus 3 over 2 is negative 5 plus 3 is negative 2 over 2 is negative 1, and negative 5 minus 3 over 2 is negative 8 over 2 is negative 4. So those are our roots, negative 1 and negative 4. So our domain here is all real numbers. So thinking about our range, okay, if we graphed our function, what it looks like. Okay, we know that the vertex is at 5/2, which is 2.5, and 9/4, which is 2 1/4. And it's going to face down, and it's going to cross the x-axis at negative 1 and negative 4. So here's negative 1. Oh, whoops, both of these were negative signs. So these should actually both be positive. And I could tell by looking at my graph that something between my vertex, something had to be wrong there. Okay, so my vertex is right about here. So here's my graph. So my range has to be y less than or equal to the y value of my vertex, which is 9/4. Okay, it's increasing on the left-hand side, so it's going to increasing starting at negative infinity until it gets to the x value of the vertex, which is at 5/2. And then it starts decreasing at the x value of the vertex at 5/2. And it's going to decrease the rest of the way, so it's going to decrease through infinity. Alright, we're going to look at one more problem, and that's where you're given the factors. And this is actually much easier to go from the factors to the standard form. So you're starting off with this. Okay, all you're doing is foiling the factors together. So x squared plus x minus 3x minus 3. Okay, I'm going to combine my like terms inside first. Minus 2x minus 3. Then I'm going to distribute my 2 inside. So 2x squared minus 4x minus 6. And to get my standard form, I just put a y in front. 2x squared minus 4x minus 6. So to go from there to my vertex form, y equals 2x squared minus 4x minus 6. I divide everything by a, so I'm dividing everything by 2. X squared minus 2x minus 3. I'm adding my constant to both sides. Now I'm completing the square. Half of negative 2 is negative 1, negative 1 squared is 1. So I'm adding 1 to both sides. So I combine my like terms, and I'm factoring this, which factors to be x minus 1 squared. So I subtract the 4 from both sides. And the last thing to do is I have to multiply both sides by 2. So y is equal to 2 times x minus 1 squared minus 8. So that's my vertex form, which I don't want to mess it up too much. So that would go in this box right here. Okay, so that would tell me my vertex is a positive 1 and a negative 8. Oh, I wrote that in the wrong box. I'm sorry, guys. That's the vertex. A positive 1 and a negative 8. Okay, to get the roots, the factors actually tell us what the roots are. We could have written that from the very beginning by saying x minus 3 equals 0, so it's a positive 3, and x plus 1 equals 0, so that's a negative 1. Domain, again, is all real numbers. So to get the range, the increasing interval, and the decreasing interval, again, we want to think about the graph. Okay, our vertex is at 1, negative 8. So my vertex is here. Okay, my a value is positive, so it's going to point up. My roots are at 3 and at negative 1. Okay, my x-axis goes from negative infinity to infinity. Here's my vertex at 1, negative 8. Oops. So, the range. Range is y values. It's everything above this. So it's y greater than or equal to negative 8. Okay, the increasing. Okay, it's increasing on the right-hand side. So it starts increasing at negative 8, and it's going to increase the rest of the way through infinity. Okay, it's decreasing on the left-hand side. So it starts decreasing at negative infinity, and it decreases until it gets to the vertex at 1, which is what I should have put there. Alright, please continue working on this stuff. Keep practicing the problems and come into CAB morning if you still have questions.